me out. How do I draw the diagram? How do I start? There's different ways of thinking about this. So there's at least two sort of very different ways to think about this. Jaden, you want to start? You drew a horizontal line. Okay, good start. Riley, continue.
Okay, well, I drew a point where they both started at.
Yes?
Like, one guy ran at 130, the other at 190, so that's a 60-degree difference. So I drew that angle, which was kind of like a 60-degree angle.
Nice.
And
Now hold on. I'm going to stop you right there. This is interesting. So something that you do in grade 11 is we think about the 360 degrees of the Cartesian plane, right? And there's two ways you can think about it. In grade 11, you do trigonometry on the xy plane, the Cartesian plane, and angles always start from here and go around. But then if you're doing like cartography, or I don't know, cartography, like geography or like maps or navigation or something, you tend to start from north, east, southwest, right? We don't have that in this question. It doesn't say what direction, so it doesn't matter. If all you did, like Riley said, is realize if one person's running at 130 and the other's running at 190, there's a 60-degree angle between them, and you drew a triangle with a 60-degree angle, you got it, right? That's all you need to solve this. However, there is this thing that's coming where we start from the x-axis to measure angles as a standard. Where would that put my line for 130 degrees? Who can help me with that? By the way, I saw some people in this room do this. They kind of had, like, I don't know if it was a full XY plane, but they had lines drawn as a reference point. Where would 130 degrees, you guys did this. Where would that put me? Liam? Okay, so I'm going to go, this is going to go around. You mean all the way around there? 130 degrees.
yeah,
From this point. Everybody happy with that? Tara?
It should be like on the other side of the second line. So there kind of, yeah.
Why?
Because like across the horizontal line it's like would be 183.
Right. So if you get all the way here, that's 180. We're not that far. We're back from that, actually, even a little bit further back. So this line should go something like that. Okay, very good. That's 130 degrees. So where's my 190 degrees? Jaden? Yeah. Whoop. Uh-oh. Yeah. Whoop. Too long. Right? He's going that way. And I'm going to get rid of that arrow, though, because that might confuse us. Okay, so that one, all the way to there, is a bit more than 180. That's too much. That was bad, but that doesn't matter. Again, a bit more than 180, 190. So it's in that quadrant. And it is kind of useful. Oh, jeez. It is kind of useful to draw at least somewhat looking like a 60-degree angle. So if it's 130 to get all the way here, and then 190 to get all the way there, then this difference here, as Riley said, is 60, that's the part we actually need to solve this, that this is 60 degrees. All right? That's one of the important steps of getting this started. But there's another thing that you need to think of and realize in order to label this triangle, get it drawn properly, and then you continue. Okay? How do you do that? Give me one of them. So Ted was running 7 meters per second, so a lot of people go 7. But that's a rate. That's not going to help us. We can't solve these things with rates like that. But 7 meters per second for 5 seconds is 7 times 5, which is 35. And once you have those two ideas, I'm going to make this line a little bit longer. So that makes, what's this one then? Alan? 25 meters. And how do I finish my diagram so I can solve? Jaden? Because this isn't even a triangle yet, but oh, now it is. How far apart are they? There's my x. And what do I use? So this goes back to the bus cancellation day where a lot of people missed, and we have to decide which law we're using. Are we using sine law or cosine law? Why?
Because we have the trapped angle between them.
Nice. Yeah, we have two side lengths and the angle between them, the contained angle, and we're finding a side length, so that's cosine law. If you haven't found it yet, go ahead and try. We're going to use this. C squared equals A squared plus. Okay, go ahead. Finish that off. Okay, when I subbed everything and rearranged, I got that. Anybody have, what's the actual answer? Jaden? 31.2. Anybody else get the same thing? Meters. I can see like the practical application of this. Boats in the water actually traveling away from a port or towards a port, or planes flying in the air, like coordinating how close they are, how far apart they are, that kind of thing, right? I mean, it would be a little bit more complicated because they don't just start at the same point at the same time, but you can see how, you know how they call it like triangulating your position? You can see how it's kind of all related, right? Like that's a little bit of a different idea, but anyway. Okay, any questions?